So isotopes. So all atoms of a given element have the same number of protons. But the number of neutrons in that nucleus can vary a little bit. And so this is a modification of Dalton's original theory. He said that all atoms of a given element are identical. They have exactly the same mass. Well, it's not quite true. They all have the same number of protons, but they don't all have the same mass because the number of neutrons can vary. So isotopes are atoms that have the same number of protons, but they have different numbers of neutrons. So they're like different versions of the same element. Some elements do not have isotopes. They only have one kind of atom. All of them have the same number of neutrons. Some elements have 2 isotopes, some have 3, some have 4. You can't get this information from the periodic table. It does have its limits. But every element has its own unique natural abundance of isotopes. So if an element has 2 isotopes, that doesn't mean that half of them are one and half of them are the other. It could be that 10% are the one isotope and 90% is the other isotope. But overall, no matter where you get a sample of that element, the relative abundance of the isotopes is going to be almost exactly the same. So let's look at an example. This is neon. So this is a neon sign, and that distinctive orange color actually comes from the element neon. That's why it's a neon sign, is because it's element neon. So neon has 3 different isotopes. It has one called neon 21, neon 22, and neon 20. And so if we were to look at the isotopes in these tubes here, the neon, what we'd see is that 90.48% of those atoms are neon 20, this particular isotope. 9.25% of them are neon 22, and only 0.27% are neon 21. So if you went to England and took some neon out of a sign at an English pub and analyzed it, you'd find the same percentages. Doesn't matter where you get the neon, the percentages are going to be the same. So we have several different ways of symbolizing individual isotopes. They all give basically the same information. One common way, this is generally called a nuclear symbol. So you take the element symbol, like here, neon, Ne, so that's the element symbol. And then we're going to put 2 numbers on the left side of the symbol. One is a superscript and one is a subscript. The superscript is going to be the mass number, and the subscript is going to be the atomic number. The atomic number is the number on the periodic table. So if you find neon on the periodic table, 10 is its atomic number. That tells me it has 10 protons and 10 electrons in a neutral atom. It does not tell me how many neutrons there are. The 21, 20, and 22, those are the mass numbers. So the mass number is the sum of the number of protons and the number of neutrons. Remember, the neutrons and the protons are what make up most of the mass of the atom. The electrons are really, really small, and so we can ignore them most of the time in terms of mass. So the mass number is given the symbol A. Again, don't ask me why, because I don't know. I would have done that differently, but there it is. So the number of protons plus the number of neutrons. So if we're looking at this symbol, let's just do the one in the middle. So 21 is the number of protons plus neutrons. 10 is the number of protons. So how many neutrons are there? 11. So if this is like stacked up to subtract, 21 minus 10 is 11. There's 11 neutrons. How many neutrons on that one? 10. 10 neutrons. And this neon 22? 12. So the mass number is the protons plus the neutrons. So if you want to know the neutrons, then you just subtract the number of protons. So the number of neutrons is the mass number, protons plus neutrons, minus the atomic number, which is the number of protons. Another way to notate this, doing that stacked subscript, superscript thing is a real pain on a typewriter, or, nobody uses this anymore, but or even on a computer. It's a pain. So there are other ways of notating an isotope without using superscripts and subscripts. So one way is to use either the chemical name or its symbol and a dash followed by the mass number. We really don't have to tell what the atomic number is, because anybody who's interested in this is going to have access to a periodic table. You can just look it up if you need to know what that is. So in this notation, the three isotopes of neon would be Ne20 or neon 20, neon 21, and neon 22. So this tells me the element, and this tells me the mass number, the number of protons plus neutrons. If I need to know the number of neutrons, I find neon on the periodic table. I see it has 10 protons. I subtract that from this mass number, and that tells me how many neutrons. So what are the atomic number, the mass number, and the various symbols that would indicate the chlorine isotope that has 18 neutrons? Well, first we need to know, how many protons does chlorine have? 17. So it has 17 protons, and this is telling us that this particular isotope has 18 neutrons. No way to get that off the periodic table. So the atomic number has the symbol Z. What's the atomic number for chlorine? What defines it as an atom? It's the number of protons. So the atomic number is 17. The mass number is given the symbol A. The mass number is the sum of these two. I believe that's 35. Yeah, 35. So the mass number is 35. That's the number of particles that have significant mass, the number of particles in the nucleus. So those are the two numbers we need to write the symbols. So the nuclear symbol would use the element symbol, and then we're going to put the mass number to the left as a superscript and the atomic number below as a subscript. The way I remember that I should put the mass number on top and the atomic number on the bottom is because if I want the number of protons, it's stacked up so I can subtract. So the larger number is always going on the top. So that's one way to indicate this. We can also indicate it with the element symbol followed by a dash and the mass number. Chlorine 35, Cl35, or we can use the name, chlorine 35. Any questions? From this problem, we get the element symbol from the periodic table. We get the number of protons from the periodic table. The number of neutrons is given to us in the problem because we need to know which isotope we're talking about. Questions? So if we're given a symbol, here, how many protons and how many neutrons are in this isotope? Well, this number down here, 19, is the atomic number. And if you're not sure, you can find potassium on the periodic table. It's element number 19. It has 19 protons, right? So 19 protons. How do I find the number of neutrons? I subtract. 39 minus 19. Well, that'd be 20, right? So 19 protons, 20 neutrons. Any questions? Compared to some of the stuff we've already done, we're just adding and subtracting whole numbers. So the hard part is, what numbers do I add and subtract, right?